So thank you very much, Nick, for having me here. So just a very small introduction about Nick. We worked together for about 2.5 years back in IBM. He's a very good friend and an amazing mentor. So I believe that today's session would be very, very good. He knows his stuff inside out. So I don't want to, waste any more of your time. So the stage is yours, and we are really glad to have you again. Thank you.
Brilliant, and thank you very much for such a generous introduction. Hello everyone, and I will attempt this, and I do apologize if it doesn't go quite right, but Kalimera, and I'm very much looking forward to talking to you guys today. As Stelios said, I'm a software engineer in the IBM event integration space. I've been working in sort of the event-driven architecture and Kafka problem spaces for getting on for about 5 years now. The most recent project I worked on was around IBM's answer to managing event endpoints. And so Stelios has asked me to be with you today just to give an introduction and a presentation with regards to why, or answers to the question, why I should manage my event endpoints. So firstly, what are event endpoints? So in traditional application development, we have REST APIs, the idea being that an application makes a request, the server processes it and responds with some information. It's very much point to point. It's a structured contract. The server typically will have an open API endpoint, and it describes the operations that are available. It describes the verbs, so whether you could do a get, a post, etc. It describes the payload, and it describes the intended response. What this means is that there have, over the recent years, been a series of API management tools developed, one of which is IBM API Connect, but there are a multitude of other RESTful or synchronous API management solutions in the market. But as we, as an industry, start to investigate and adopt event-driven architectures, then the same paradigms start to apply that we've seen in RESTful interfaces to event-type APIs. And so by an event API, what I mean is it's asynchronous, and typically it is not a request response mechanism, but instead the application you wish to interact with presents two potential endpoints. It would typically provide some form of publish type endpoint, which is a description of an endpoint that you can send messages to. And it will provide a subscription or consumption endpoint, which is where you will be able to ask your application to ultimately subscribe and listen for any events. What this also means is that in an event-driven architecture, it isn't, because it's not point to point, the messages aren't targeted for a particular consumer. What instead is desirable is that your system is composed of event handlers. So an event is a message saying this has happened, something has happened, an order has been placed, some money has been transferred, but there's ultimately no destination or intent in mind with that event. The idea is that multiple applications that can derive value from that event are able to subscribe to for example, in Kafka, a topic, a queue in MQ, maybe a webhook or a WebSocket in more traditional web programming. And the idea being that these endpoints provide the ability for clients to, as I say, send messages in and receive messages out. And the idea being that there's a single endpoint that everybody can subscribe to, everybody can publish to, and it is a broadcast type mechanism rather than a request response. So now that I've described the idea behind event endpoints, I'd just like to start to tell a little story. So it's a common scenario. Your project manager, your team lead has a new piece of work that they want you to implement. Perhaps actually they're an architect and you are a lead of a squad, but they come to you and they say, I've got this opportunity and I need somebody to work on delivering a solution. So for example, let's say he says, we've got a scenario where customers are leaving our business. We've got significant levels of attrition, and we want to be able to understand why. And ultimately, you're aware of the fact that your business has websites for placing orders, it has phone methods for placing orders. So there's a series of different ways of getting data into the system. And you think, well, actually, maybe this is an event-driven solution. You're not looking for particular communications from customers. You're looking for events that correspond to them. So as I say, the ability to be able to recognize that a customer has perhaps accessed the account closure page. Maybe a customer has started transferring money out of their bank accounts, or they've started migrating API keys, they've been deleted. Essentially, the idea being that there's a series of events that will be useful for being able to provide a ultimate solution to your team lead's problem. So at which point you think, well, you know what? This really does sound like something I could use Kafka for. I know that there are streams of external events that we've got. I know that we've got a series of APIs I could use here. And the idea being that you decide that actually, yes, a Kafka topic would be your best idea. So the first thing you need to do is that you actually go to your Kafka administrator and you say, I want to be able to create topics. I need credentials to get access to this Kafka cluster. And you have to have a dialogue with them. Maybe that's synchronous via something like Slack. Maybe it's via an approval workflow and you're waiting a few days to get access. But ultimately, you do eventually get access to this Kafka cluster and you start building an application. And you think, okay, I've got these REST APIs, I've got these external APIs, I can bring in lots of data that will help me solve this problem. But I don't know of any Kafka topics that exist with that data. So I end up, I'll just turn my light off. Sorry, I realized my light bulb's about to break and that was strobing. So you bring in all these sources of data, you publish them onto a Kafka topic. That allows you to start building your application. You can write your code that's consuming from Kafka. You can do maybe some event processing, some enrichment of the streams to be able to predict when a customer's going to churn, and you can then take some action from it. You could build an application that would send the customer a voucher to make them perhaps buy some more from your website. Maybe you send them an email asking for some feedback, etc. But what happens is a few days later, you're in the team room, you're having a coffee, you're chatting with some other developers from a different team in your organization. And you start to describe the fun that you've been having, the fact that you've been enjoying exploring the Kafka technology, you've been having to pull in these external APIs, sources of data and build your own Kafka topics to start getting customer information. And your colleague gives you a bit of a quizzical look and says, did you not realize we already have these Kafka topics available? I've been working on this data from my cluster for weeks. You didn't need to go and actually create your own topics. You could have just used the messages that were on ours. And of course, that's frustrating. You've wasted development time. Yes, you've learned some skills, but ultimately there was a big chunk of your application that was unnecessary. If you'd have known about this Kafka topic, you'd have been able to consume the messages accordingly. So you go back to the drawing board. You think, actually, I don't need to reinvent data that already exists. There's a high chance that I maybe have made a mistake. I'm not the domain expert, whereas my colleague's topic, I know I can trust that he has the right information on there. So of course, he's then given you access to it. Again, another set of workflows to get credentials. But you connect into his Kafka topic and you start consuming the messages and you can start using that to build your application. But then you hit another problem, because you now need to interpret the messages that have come off this topic. So although he's given you access, and yes, you can connect to Kafka consumer, you've got a stream of bytes coming off the other end. And you've got no idea whether that's meant to be JSON, whether you should be parsing it into some form of serialized object. or maybe it's just a straight string. It's not clear from the messages coming out what the interpretation is. So you then have to go back to your colleague and explain that it's great he's offered you these messages and access to the topic, but you now need some help from him to help understand how you can actually consume those messages in your application. So this story shows a few problems. We have the consumer problems. I need to be able to know where I can find topics of interest. I don't want to be having to create topics all the time if those topics already exist from other developers. I have to figure out who can give me credentials. I've ended up going to 2 different Kafka administrators, getting credentials for different topics, credentials for different clusters. And I've now got to manage and remember which of the credentials are valid for each of the individual Kafka clusters I'm connecting to. I've had to understand the format of the messages. I needed to get some information from the owner of the topic that allows me to write my Kafka application in such a way that I can read the messages coming off the topic. And finally, in Kafka, it's not as simple as a REST API. I can't just do a curl command or a standard web request. I need to get a Kafka client configured to point to the topic. I need to know the Bootstrap servers. I need to know the endpoint address. I need to know whether there's some security or encryption. I need to know the type of credentials I need. Maybe it's a mutual TLS certificate. Maybe it's a username and password. And all of this is compounded by the fact that I've had to consistently ask each of the individual administrators where all this information exists. And then from the administrator, they've had the same challenges. So they start to wonder, well, how can I automate granting access to an event stream? I don't want to have to go through this workflow every time somebody wants to access my topics. In the same respect, I've now got to remember that I've given out access to a series of colleagues. How am I going to remember what credentials I gave to which user? If I wanted to just restrict access to a couple of topics, I need to start keeping a log of who has a particular API key, who has a particular username, etc. And in addition, I also might just simply want to monitor and identify who's accessing my servers. Kafka by itself does not necessarily provide out of the box any form of monitoring with regards to clients. Typically, most products in the market that offer any form of monitoring of client usage of a Kafka topic require you to provide a custom Kafka client in a particular language to your users, which is no good if you've got a series of teams that all want to start consuming from a topic. You also, as well as granting them access, don't want to have to manage a whole workflow of providing them information to tell them the types of clients they're able to use. Kafka is an open protocol. They should be able to use any clients that they wish. So both of these sets of problems, the consumer problems, the administrator problems, lead us to needing to understand a solution, why and how you should actually provide some level of management of event endpoints. As I said earlier, in the synchronous, the RESTful API type approach, API management solutions exist for this exact reason. They provide ways to access APIs, ways to provide some form of self-service of credentials, ways to provide documentation for anybody who needs to discover and consume those RESTful APIs. So if we apply the same paradigm to event endpoints, then we still start to look at needing solutions that can do similar things. So we need to enable discovery. And by discovery, I mean the ability for a user to search a catalog of event streams, to be able to actually go and find, yes, there was a topic that has the customer data I'm looking for. Yes, there is an MQ queue that contains the latest order status. I need human readable descriptions. I need to be able to look at the catalog and actually understand which topics are appropriate. Just being told, well, there's a topic named customer on the, excuse me, a topic named customer doesn't help me if there isn't some form of human readable description, something that explains actually maybe this topic is used by a particular business, part of the business that is dealing with high value customers. Maybe this topic actually is all about customers that are predicted to leave the business, etc. So I need some form of human readable description, some metadata to allow me to discover and search for the important event streams for me. And perhaps I need some form of external documentation. Maybe there's actually some other business workflow that has been implemented on top of this API. So I need to be able to provide some level of outside links that would be able to allow users to find and understand additional documentation. Maybe it's even something as simple as providing links to tutorials around Kafka, because you've implemented Kafka endpoints in the business, but you're the first team. And so you want to make sure that you can easily enable others to be able to consume and understand the Kafka protocols, the Kafka paradigms. And so you can point to external documentation within your published endpoints. And of course, once I've discovered a topic, or a source of event messages, I want to be able to evaluate it. I need to be able to look at the shape of the events. I need to be able to understand what a message would look like before I can even consider trying to consume it in my own application. I need to understand the intent of the stream. So not just the shape of the events, but if I can see some sample or some live data, maybe the fact that it's called customer and the customer status is described in the schema. If I can see the live data, I can understand that actually the majority of the messages coming through this event stream are at high value customers, or they're about customers that are eligible for discounts, etc. And then I need to be able to consume the data in my application. So I need to be able to perform some form of self-service sign-up, some ability to request access that is automated in such a way that the Kafka administrators are not being inundated with requests. I need to be able to see where the endpoint is to be able to connect my configuration client to it. I need to be able to see any specifics for the client in terms of configuration. So as I said, some form of description and indication of the types of credentials, the types of security, types of encryption that are on the particular endpoint. And actually, maybe I need some form of sample or bootstrap code to get me up and started. So rather than having to learn how to write a Kafka application, the event endpoint management solution could provide an example of what a client might look like. And then finally, from the administrator perspective, there's also some thoughts about security. So rather than having every Kafka administrator being sent requests or having automatic workflows to gain access to clusters, if you use something like an event gateway, a proxy in front of other Kafka brokers, what instead you could look to do is to provide a single secure path via the event gateway, where everybody will sign up for access for credentials, and it actually hides the real servers. It can proxy requests onto other Kafka brokers, other MQQs. And the idea being that the individual consumers are only ever going through this single event gateway, which means if you ever want to revoke access, you can revoke access at the gateway level, and it removes any access through the gateway into other sets of clusters. And perhaps actually you've got a series of development clusters where it would be particularly challenging to add security to it, because it would start to break some of the development processes. You didn't want to add security until maybe your QA server. So by putting a gateway in front, you could actually say, well, the gateway's job is to add security to these clusters, so we can leave the infrastructure as is, but the gateway provides a secure way to access through it. So there are a few solutions to event endpoint management that are currently in the market. One particular of interest is AsyncAPI. Now, the idea behind AsyncAPI is that it's a specification that has been influenced by OpenAPI, and it's used to describe the streams of events that are available for consumption or for writing into. The idea being that it can describe the channels of streams that are available. It can describe whether you can publish or subscribe to them. It can describe the content of the event stream, the schemas, the structure. It could include some human readable metadata. And the idea being that by using AsyncAPI, just like OpenAPI, it's a specification that everybody can align to, and it becomes a document that is both human readable to be able to understand your event endpoints, and it is also machine readable. You could use an AsyncAPI document to generate a new client. You could use it in source control as a way to be able to document APIs. You could even use it as a contract so that you actually have contractual agreement before anybody implements any applications, that as long as they conform to the async API, then their event-driven applications will be able to function accordingly. And so, as I said, an async API document, it's typically YAML or JSON, and it's structured in such a way that you can provide human readable information in the info section. You can provide access to servers. So you can simply say, well, an AMQP topic exists on this URL with a description associated with it. And then you provide access to the channels, a description of the particular channels or topics or queues, etc., depending on the messaging protocol that are appropriate for use. So in this example, we can see that on the AMQP broker, there is a channel called hello, and that you have the ability to send messages in by publishing a message to that hello channel. It even tells you that the payload you need to send through is of type string with a particular regex pattern that explains the structure of the messages. Of course, if you've got something like Kafka, where typically the structures are more formalized in Avro or in a JSON schema or protobuf, then AsyncAPI provides sections in the payload where you describe the schema that is associated with the message. And of course, by documenting the schema in the AsyncAPI, it means that anybody who wishes to consume or to write into the particular channel is able to very quickly start up an application that will be able to send the correct messages onto the topic. And of course, when you start using a more formalized document to describe your event endpoint, you can use things like generators. So the AsyncAPI community have a series of generators that can be used to generate application skeletons. So you give it a AsyncAPI document and it will generate you a Golang program or a Java program or a JavaScript program that will be consuming or writing events into the particular stream of events. Or you could use it for generating human readable documentation. So actually, given an AsyncAPI document, you could use the documentation generator to generate a Jekyll static site for documentation. Or you could use it to generate an interactive API explorer, much like how OpenAPI have explorers as well. And the idea behind these documents is that they provide a formalized method of describing and discussing your APIs. They provide a formalized method to be able to share information between individuals so that you can easily discover and understand the contents of a particular event stream. And if you build them into a catalog, you can use the metadata inside the document, the info section, to provide a searchable manner in which you can discover and find your event endpoints. And as I said, with regards to gateways, an async API could be used to generate a particular gateway structure that you might want to put in front of your topics. Or alternatively, as part of your event endpoint management solution, you could use your async API generator as an async API document as input into your gateway to generate a new endpoint that is protected and obfuscating the underlying Kafka structure. And so this is ultimately the product that IBM have built. So we have a product called IBM Event Endpoint Management. It provides the ability for you to have self-service subscriptions to event streams. So you can sign up an account and browse through the catalog. And if you find an event stream you're interested in, you can subscribe to it using a generated set of credentials. The idea being that every set of credentials is protected using a gateway. And so administrators can log on to the dashboard, and they're able to see who is subscribed to particular sets of event streams. They can revoke access, they can restrict access. You could even potentially look at ways to limit and control access to particular topics rather than just a general access to a Kafka cluster. We have built our own catalog of event sources, the idea being that you have a way for somebody to document and describe their event source and publish it to a catalog for everybody to discover, thus satisfying the need for new developers or somebody starting a new application to be able to search and find the data that they're interested in, rather than having to build their own endpoints. And we use AsyncAPI as our document format. Simply by keeping to an open standard, it means that inside our catalog, if somebody were to download the AsyncAPI, they could generate their own applications. We can use the AsyncAPI to generate our own sample code. And it means that we can be aligned with the growing open specification for providing the documentation. And so the ultimate idea and the point that I wanted to get across today is that event endpoints, whilst they are not the same as REST, they're not point-to-point communication, they are more broadcast based. They should be treated and managed in the same way. And when you start to look at event-driven architecture, it would become very challenging to build an architecture that can be consumed and developed by multiple people without having some form of formalized solution for managing those endpoints, describing those endpoints, and socializing those endpoints to allow discovery to take place. And so I'm not advocating, obviously, that event endpoint management is the only solution. We've taken these concerns on board and built them into the solution that we've delivered. But ultimately, what I've described today are a series of principles that should be considered whenever building and growing an event-driven architecture, or even simply just looking at being able to share Kafka topics around departments within different areas of an organization. A formalized description and versioned management solution just makes it a lot easier for developers to be able to be effective earlier. They won't need to waste time on building their own sources of data, because there's already then documented and well-known and well-structured topics that are available for usage. So that ends my presentation today. I'd just like to open the floor up to any questions with regards to what I've discussed.
I was going to ask the same. If anyone doesn't have a question, I have actually. I can wait for no one. Cool. So I have a question, actually not purely related to how we're going to manage event endpoints, but in general about AsyncAPI, because what we're trying to do recently probably lies around the image of AsyncAPI. So I wanted to ask, for example, what we're trying to do is instill an idea of contract testing with packed row. However, the way you described it, you can do it that easily as well. And I was searching in parallel, and there's this solution, MicroRocks, it's called, which, by the way, Streams is using. And I was thinking, first question is this. The second question is, we have a service. This is called the test data management, basically. So what it does, it generates very quickly through a flow of multiple services some test data. So it, let's say, it bypasses some of the checks that normally you will do if you follow the normal external hit through reverse proxies, etc. So in such cases, what they do in order to help be in line with the versioning of the services, they use Swagger CodeGen to build the client that you just mentioned. Is it something that we can use AsyncAPI for example?
Yeah, so so to your first point, so MicroRocks has got support for AsyncAPI in it already. So you are able to give, in MicroRocks, supply an AsyncAPI document, and MicroRocks will parse that document and start generating test data into your broker or your MQ, queue, etc. Purely based off the contents of the document. So it will be able to read where the topic exists. It can read the structure of the message that it needs to send through. If you supplied a schema, say with JSON schema, then typically you can provide more regex type approaches to help MicroRocks generate the more structured and realistic test data. With regards to client generation, so the challenge that AsyncAPI faces at the moment is that it is an evolving and fast-growing specification. So it's not quite as stable, perhaps as Swagger and OpenAPI are. However, what it does have is good focus from the community with regards to those generator projects. So at the moment, I am aware of the ability to give the generators an AsyncAPI document, and it will provide a very simple application that will push some messages to the topic or consume some messages from it. The biggest challenge with the generators at the moment is simply that Kafka support in AsyncAPI is limited. There are scenarios whereby Kafka and to some extent MQ, the generator cannot build absolutely everything for you. In particular, when schema registries are involved, because if your schema is actually, for example, you've got the Confluent schema registry, typically that requires you to use a Confluent schema registry client to actually produce and consume messages from a topic. The challenge with this is that the AsyncAPI is not currently designed to be tied to a specific Kafka vendor, which means that it doesn't have any knowledge of the fact that you would need to build an application that uses the Confluent schema registry. So I would say that AsyncAPI and client generation for running tests and for populating test data, a mixture of Microps and the AsyncAPI generators should provide you a bare minimum the initial set of bootstrap pieces. I think you would probably be best to investigate and potentially raise pull requests or requests from the community to enhance it, where you find the inevitable gaps. But the concepts that you described with regards to Swagger and contract testing can definitely be achieved using AsyncAPI in the same manner. It's just that it might not, as I say, be as mature a technology as with RESTful API generation.
Yeah, okay, no, that makes sense.
But certainly from a contract testing perspective, you should be able to use AsyncAPI as a agreed contract between producers and consumers in such a way that it can be used within contract testing to provide that assurance between the two interaction points.
Yeah, okay, yeah, that makes sense. Thank you very much, Nic, for your time. Let me